All right, we're going to go ahead and start talking through stuff. And if we get people that show up because of late buses, I will let them in and we'll go from there. So we're going to do this with some long division. It's the only option we have right now. So seeing what we remember, what will we put up here? See if we can figure that part out. What's going to be the very first thing we put up here? Yeah, we're going to put a 2x squared up there. We look at our first term, our x, and our first term, the 2x cubed, and we figure out x times what would give me 2x cubed. Or you can set it up as its own little baby fraction to simplify. Our 2x cubed divided by x. Either way, we should get 2x squared as our first term in our quotient. We're going to take it, we're going to multiply it, we're going to put it under. So 2x squared times x gives us that 2x cubed we were looking for. 2x squared times minus 2 gives us a minus 4x squared. Then what we need to do is we're going to come through here and we are going to subtract my 2x cubed from my 2x cubed. And I need to subtract the minus 4x squared as well. Minus the negative turns it into a plus. So just be really careful. Make sure we are subtracting everything, which means we have to change that sign if it's a minus sign. When we do that, my 2x cubed minus my 2x cubed cancels out and gives me a 0x cubes. That first term should always fully cancel out. If it doesn't, something went wrong. And then we get negative 7x squared plus 4x squared, giving us a negative 3x squared. And then I'm just going to drop my next term on down. I can drop both terms if I want to. Don't have to, but you absolutely can. So that's our first, cycle on our long division here. Questions on that bit? Because then we get to do the whole thing again, at least one more time. Because I can still divide an x out of this minus 3x squared. So we get to do that whole cycle again. So I'm going to look at this first term, our minus 3x squared divided by x. Or we can think x times what gives me negative 3x squared. What's going to be our next term on the very, very top? It's going to go here. Super close. Less close. The negative 3, yes. Negative 3 and an x. Because this is negative 3x squared. So that's going to make one of the x's cancel out. So just trying to do this. So this x is going to cancel out with one of those x's. I'm just going to be left with my minus 3x. Because I need, when I multiply my minus 3x times my x, it needs to wind up at exactly negative 3x squared so that everything cancels out. So when we do that multiplication, when I take my minus 3x times this whole piece, and then we put it under here, that's going to give us our minus 3x squared. Minus 3x times minus 2 gives us a plus 6x. And that's when we need to remember that we are subtracting both pieces here. So I'm subtracting my negative 3x. That's the same thing as if we add 3x. And I'm going to subtract my positive 6x. So negative 3x squared plus 3x squared gives us 0x squared. And then my my 7x minus 6x is just going to give us 1x. So our x squareds canceled out. That's what we expect to happen. And we're left with just 1x. And then this guy's going to drop on down, minus 2. And we have one more cycle to do. Because our last cycle is going to look at this first term. So we're going to look at our 1x and our first term, x. So if we just have 1x divided by x, what's going to be our last term up in our numerator? 1. It's not that it goes away, it's that x times 1 gives me x. So we do still have a term here. We're going to need to multiply that, so I'm going to grab my 1x, or my 1, multiply that times the whole factor, and put it underneath here, giving us our 1x minus 2. Then I need to subtract my x and subtract my negative 2. When we subtract negative 2, that becomes a plus. 1x minus 1x gives me 0 x's. Those cancel out. First term always should. Negative 2 plus 2 gives us 0, which means we have no remainder. Whatever this very last term is would be our remainder. So when we have our 2x cubed minus 7x squared plus 7x minus 2 divided by x minus 2, we get 2x squared minus 3x plus 1. And if you want to check that, you could always multiply the x minus 2 times this whole thing, and we should get exactly this guy. Questions on this bit? Because we are going to use a different kind of division today. Because long division, while functional, is, in fact, long and repetitive and long. And I don't wanna, because it's long. And I get it. So I'm going to show you a kind of shortcut that we can use for this division. So we are going to be in our notes packet. We are going to be on page 17 of that notes packet. And we are going to start by talking about something we talked about at the very beginning on Friday as well, because it's incredibly important. And that is the difference between a factor and a root. So we've talked about this before. We talked about it on Friday. The root is what we get when we have an x equals. So x equals whatever our root is. Root. If we have it written as a factor, that's when we have our x minus r. So this whole thing is the factor. So the r itself is the root. It's what we get when we finish solving it. The x equals. That's our root, our solution, our 0, our x-intercept. The x minus r, that's when we have our factor. And it's very, very, very important because we divide in our long division by the factor. We divided by x minus 2 in the bell work. That's a factor. So if we have a root of 4, that's what this first question says. We have a root of 4, x equals 4, is our solution. What factor would that be? How would we write a root of 4 as a factor? But we got to have the whole thing. We got to include that x too. So the factor would be x minus 4. So the factor has the x in it. The root is what x equals. So a lot of times that will be when we take our factors and we set them equal to 0. So when we get kind of funky factors like this guy, 2x plus 1, it still absolutely counts as a factor. However, to find the root, what do I need to do with that 2x plus 1? Set it equal to 0. So we can solve this. I can subtract 1 from both sides. Get that 2x equals minus 1. What's our x going to equal then? We'll have to divide both sides by 2, and that's going to get that x equals negative 0.5 or negative 1/2. Genuinely doesn't matter. Both mean the same thing. But the factor has the x minus part on there. The root is just the number. When we do long division, like we did in the bell work, we use the factor to divide. So we're going to divide by x minus 4. We'll divide by 2x plus 1. We'll divide by x minus 7, x plus 3, anything like that. When we're using our new technique today, our kind of shortcut mode, that's called synthetic, and it uses the root. So we're not going to have to write the full factor out. It's going to give us a much shorter way of writing out these problems and doing this division that's not near so long as long division. Long division has its purposes and has its reasons. When there's time or when there's an option, synthetic division is significantly faster. Synthetic division uses the root, so we are going to need to make sure we can find roots, which means anything that doesn't have a real root cannot be divided with synthetic division. That's what that's meaning. So we have times when we will have to use long division, but we are going to be able to use synthetic division too. So just to kind of practice this again in the middle of the page here, we have a polynomial with a factor of x plus 7. And we're going to practice by making sure we know our factor and our root for these pieces, because I have one that we've given a factor, one that we're given a root. So for long division uses the factor. So we are straight up told this has a factor of x plus 7. So for long division, we would divide by x plus 7. It would be set up on the outside of the house like this. We'd put whatever our polynomial is inside. We're dividing by that x plus 7. That's our guy. When we're using synthetic division, we need the root. What would the root be for this factor? Negative 7. You can either think of this as our x minus r and kind of brain it that way. You can take your x plus 7, set it equal to 0. But we get x equals negative 7. So negative 7 is the root. So the x plus 7 is the factor. Negative 7 is our root. So if we have a polynomial with a root of 9, what would the factor be for long division? Yeah, we would straight up write this as x minus 9. That's how we put this into a factor. It's x minus our root. For synthetic division, we just use the root. So our root for synthetic division is just that 9. So it's really, really important. When we're working with long division, we use the factor. When we're working with synthetic division, we're going to use the root. The very bottom of this page gives us our very first walkthrough on synthetic division. And it's kind of built off to the side. I'm going to walk you through what the heck this nonsense means. This right here is the setup for synthetic division. This is the same thing as if I took this problem right here and wrote it out as long division, how we did before when we had our x plus 3 and we were dividing that into this whole big old thing. I can write it this way. This would be my 3x to the third minus 2x squared minus 53x minus 60. This is called writing the coefficients. So it's the numbers that are next to each of the letters. They have to be in standard form, so biggest to smallest exponents, and I cannot skip any numbers. Yes, dear. Yeah. So, I'll write you past your So that means I can't skip x squared. Like if it didn't have an x squared, I have to put a 0 there. So I can't skip any terms. But I can do it without having to write the letters down. It's just putting the numbers in order. So we take all those coefficients, we line them up in order from our x's. And then this first coefficient is always going to drop. It's just going to straight up fall to the bottom. So whenever we set this up, we're going to put our coefficients here. We get our root, and it goes in this little box in the corner here. So this is how we set this up. In order to do the actual multiplication, what we're going to do is we take what's on the bottom times our root, and we're going to put it under here. So I'm going to take this 3, this one just fell on down, times our -3, and we put it under. So I'm going to take this 3 times the -3, and we're going to put it underneath. So we get -9. Then instead of subtracting, this is the other big difference between our synthetic division and long division. Instead of subtracting, what we're going to do here is we're going to add. So I need to add -2 plus -9. And we're going to get -11. In just that amount right there, that is one entire cycle of long division. That's one whole row in a long division polynomial in these two numbers. Much shorter. And then we get to do it again. We're going to take the bottom times the left and put it under. So I'm going to take my -11 times -3 and put it under here. Well, -11 times -3 is going to be a positive 33. Then we add. -53 plus 33 is going to give us a -20. That would be a whole nother row when it comes to long division. One more time. Bottom times the left and put it under. -20 times -3 is going to give us a positive 60. And when we add those together, -60 plus 60 gives us 0. This last term, whenever we're doing synthetic, this is always going to be our remainder. Every single time, that's our remainder. What these numbers are to the left of our remainder, these are the coefficients of what would be on top. So it's always going to be our number, just constant, at the end here. And this is going to be an x, and then our next piece would be an x squared. It's always going to kind of count up. So I'm just going to mark that down. So this piece is always going to be just a number. And then it's going to go up by degree. So this one's going to be with an x. This guy's going to be with x squared. You can also go, well, this is an x cubed, and I'm pulling out an x, so I'm going to be left with some sort of x squared situation, which is true. So our answer for this polynomial, we just got to combine these pieces together, where we're going to have our 3x squared minus 11, not the color I wanted, x minus 20. This is what we get when we divide that 3x cubed minus 2x squared minus 53x minus 60 by x plus 3. That is our result. If we want to check it, we could always take this trinomial that we got as our answer times what we divided by, x plus 3, and we will get exactly what we started with. We are going to practice this several times because the setup is the part we get the most confuddled on. Questions on this first one? Okay. We are going to look on the next page at a few examples of this. We've got our 3x squared plus 11x minus 4. And we're told that one of the roots is negative 4. So what that means we are expected to do is we are expected to divide out our root of negative 4 to figure out what's left over. So we're being told some information that our root is negative 4. So this is an important piece of information. This is our root. When we're getting ready to set up synthetic division, an important thing for us to look at is to make sure we're not missing any of the x's. I've got 3x squared and then 11x and then just a number. So we're not missing any x's. We don't have to have a cube. We don't have to have a fourth. We just need to make sure we're not like missing a number in the middle here. So when we set this up, what we do is we're going to take all of our coefficients from our polynomial. So I'm going to take my 3 from in front of the x squared. I need my 11 from in front of the x. And I need my minus 4 from the end over here. So those are all my coefficients. Then we have over here kind of separated out. We tend to use this little box thing to put our root in. This would be our root of negative 4. There are some places that do it slightly different. If you look online, some people will do it in kind of like an upside down division house. There's some places that just uses like a bar like this, which that feels really confusing to me. We tend to just put it in this little box off to the side. There's not one universal indication for that, but that's the one that we tend to use. So that's the one we kind of expect you guys are probably going to use because that's how we do it. I'm going to skip a line and draw a line. We know we're going to have to write stuff here, so don't just like put your line across directly underneath these. Leave yourself a little space because we have to write things underneath. It's part of the process. Questions on this part? It's our first time building it. Okay, that first term is always, first one of the party, just drops it. Every single time. This first one just straight up will drop down. No calculation needed. Boom, false. Every time. So then we're going to go bottom times the left and put it under. I'm going to have my 3 times my negative 4. And we're going to put it under here. So that's going to give us 3 times negative 4 is negative 12. So 3 times negative 4 gives us that negative 12. Then we add. So we need to add 11 plus negative 12, which is going to give us a negative 1. Then we get to do that whole cycle again. We're going to take the bottom times the left and put it under. Negative 1 times negative 4 gives us a positive 4. And then when we add those together, negative 4 plus 4, we get a 0. More often than not, we will have it end with a 0. It does happen occasionally, and I'll show you what that looks like here in just a little bit. or maybe tomorrow, just because that's how timing is working out. This last term, every single time, no matter what, this last term is our remainder. It is not a part of our final answer unless it's something other than 0. So this last term, more often than not, is going to be 0. That's our remainder. Trash can all day today. So that means when I'm building up my answer, this guy doesn't count. He's my remainder. So this is my constant, my just a number, and this guy's going to get an x. So our answer of what happens when we divide out -4 from this polynomial is that we're going to get our 3x minus 1. Because this guy's going to be just a number, and this guy's going to get an x. So looking at this original polynomial here, my 3x squared plus 11x minus 4 is made up of 2 different factors. The one we just found, our 3x minus 1. And what is the factor when we have a root at -4? Because we know one of those roots is -4. What is the factor for that root? X minus -4. So our root's going to be that x plus 4. So our factor is going to be x plus 4. So if I multiply back together that 3x minus 1 and x plus 4, I should get exactly the 3x squared plus 11x minus 4. And that's another way you can check. So now we've got our factors. I know one of my roots is -4 because we divided it. This one, in order to find our root, our solution, our 0, we would need to set it equal to 0. So if I need to find that root, we're going to take our 3x minus 1 and set it equal to 0. Well, that's going to give us a 3x equals 1, which means what's our other root? 1/3. So we have factors at 3x minus 1 and x plus 4, and we have roots at -4 and positive 1/3. We aren't always going to have to write all of the pieces out. We're just trying to kind of make everything tie back together. Questions on this one? Let's take a look at the next one. Boop. One of the benefits of synthetic division is it is significantly faster to calculate than long division. Long division, we got through 2 examples in a whole day. We've got through 2 examples in the last 6 minutes. So I'm just saying. Synthetic division is significantly faster. When we have a root or a factor that is something that we can get a root for, highly recommend using synthetic division. There are times when we have to use long division. If we specify you have to use long division, we have to use long division. Or if we don't have a root, meaning it has imaginary numbers, so it's like x squared something, and it won't factor simpler. And a lot of times when we have fractions, it is going to be easier to do it with long division, just because the fraction roots are kind of icky. Doable, but unpleasant. So we're going to do our next set of synthetic division on this one. So the first thing we need to do is set it up. I need all of my coefficients for all of my terms here, including this guy. I have 1x cubed, so we need to have that here, minus 4x squareds, minus 11x's, plus 30. Giving us a hypothetical because we're not going to see it today. No, even if we get to the next one, we won't see this. If this did not have this piece in here, like it just straight up was x cubed minus 4x squared plus 30, we would still need to have a coefficient in the spot for x's, even if this wasn't here. So we would have to put a 0 here if that term was gone. So we need to have a coefficient for every degree of x, from whatever our biggest is down to our constant where we don't have any x's. So we have to have, if I have a degree 3, I have to have 4 coefficients. If I have degree 2, I need to have 3 coefficients. I will always have one more coefficient than the degree is. Every single time. It is very, 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 very important. Our next thing we need to have is we need to put that our root is 2. When we're using synthetic division, we always put that our root is 2. Since we're finding our roots, I know we have a root at 2. I could even come down here and put my factor. I know it's going to be x minus whatever that root is, x minus 2. I can do that. I know that piece. It's a part of this. The root they've told us is 2, which means our factor is x minus 2. And again, you could do this with long division. Long division is just very long. So I'm going to skip my line, draw a line. And we're all set up here. You do not have to put this plus on the 30. If it helps you, put it. If it doesn't help you, don't put it. But we're ready to cruise on this. First term is always going to drop. So that 1 is going to fall straight on down. And then we get to start doing our cycle. Bottom, oop, that's not the laser pointer. Bottom times the left and put it under. So we're going to have our 1 times 2 and put it under here. Well, 1 times 2 gives us 2. And then we add. Negative 4 plus 2 gives us a negative 2. Then we get to do it again. Negative 2 times 2 gives us a negative 4. And then we add. Negative 11 plus negative 4 gives us a negative 15. And negative 15 times 2 gives us, I'm out of color, gives us a negative 30. And when we add there, we get 0. Again, remembering that this guy here, this last piece, is always that remainder. So he's not a part of my final answer as long as it's 0. I don't need to put anything with 0. That means this guy's going to be my just a number. This guy gets an x, and this guy gets an x squared. So when we finish our division, we get 1x squared minus 2x minus 15. That's what we get as the result of our division. But we weren't just asked to divide. We wanted to find all the factors. So then I want to know, can I factor this more? I have an x squared here. Could we factor that more? No. Well, let's check and see. We can use our factoring tools. Where we look at our a times c over our b. Oop. A times c, 1 times negative 15 is negative 15. B is negative 2. Do we know a pair of numbers that multiplies to make negative 15 and will add to make negative 2? When in doubt on these, make a list of things that do that multiplication. Multiply to make 15. Well, that'd be 1 and 15. Doesn't divide by 2. 3 and 5. So does one of those pairs have a difference of 2? Yeah. Which one of them is going to need to be negative in order for them to add to be negative 2? the 5. -5, +3. So we can put this through the box. We can put this through factoring by grouping. We can put this through bottoms up, anything like that. This one doesn't have an a value, so we can also just take our shortcut where we're going to have our x minus 5 and our x plus 3. Which means we know all the factors here. If we get it down to a quadratic, it's something we can probably factor again. That also means I know all of my roots for this polynomial. What are the other roots we get for this polynomial? What is the root for the factor x minus 5? 5. What is the root for the factor x plus 3? Super close. -3. So we can find even more roots and even more factors after the division part. So whether we're looking for factors or we're looking for roots, those are the pieces we need to find. We're going to stop right there because we are really close to the announcement reminder. There it is.